Welcome to this video on graphing parabolas. Here is some vocabulary to start us off to look at what a parabola is and what some of the main words that describe the features would be. A parabola is a very specific kind of U-shaped graph. Parabolas are very helpful in the real world because, for example, satellite dishes are parabolic, and without the full study of the parabola, we wouldn't have the telecommunications industry that we do today, which is an amazing side note, but let's get back to the mathematics. A parabola is a U-shaped graph like this one. It can be sitting anywhere on a graph. I'll put the X and Y axis in here just to give an image. The turning point of the parabola is the vertex. If the parabola is opening upward like this one, then the vertex would be the lowest point on the parabola. The x-intercepts, of course, refer to where the parabola crosses the x-axis. No surprise, the y-intercept is the location where the parabola crosses the y-axis. And the axis of symmetry is a vertical line that cuts the parabola in half, so to speak. Parabolas can be concave down as well as concave up. They can have no x-intercepts. Some have one x-intercept. Most have two x-intercepts. They can be wide, narrow, or anywhere in between. Here's a particular equation of a parabola. We generally call the coefficients of the polynomial a, b, and c. The question that we have to ask ourselves here as we go into our first and only example is how do the values of a, b, and c affect the characteristics of the parabola? In other words, if I were to give you different numbers for a, b, and c, could you find the vertex, the axis of symmetry, the x-intercepts, the y-intercepts, and whether your parabola is concave up or concave down? Here's our first and only example. Let's take a look at this example. What I like to do is find each of the characteristics of the parabola separately and then piece it all together. Step one, I like to find the axis of symmetry first. Luckily, when your parabola is in this ABC format, as we have here, there's a formula that we can use to find the first half of the vertex, which is the axis of symmetry. So in this particular problem, look at the very top of the screen. B is 6, A is -1, and C is -5. Now look at the bottom of the screen. You'll notice there's no C in this formula, but I can plug in the B and the A from the particular problem. Since a negative divided by a negative is a positive, and since 6 divided by 2 is 3, I have an axis of symmetry of x equals 3. Now watch the graph as you will see that axis of symmetry appear. Axis of symmetry will be a vertical line, and in this case, we know it's going to be at 3. That's feature number one. The second feature I like to find is the vertex. To find the vertex, I'm going to plug 3, that's my axis of symmetry, back into the original formula at the top of the screen. Here's me plugging 3, the axis of symmetry, into the original equation. Doing the algebra, I get 4 as my y coordinate. If you want to take the time to look at the numbers and think how I got all that, hit pause and do that now. Okay, you may notice here that it looks like, if you look at the left side of the equation, it looks like I'm saying -3 squared is -9. That's not true. 3 squared is 9. The negative isn't being squared here, which is why I have a -9 in that second line. But the bigger picture is, what does the 4 mean? Well, it means that my vertex, which is on the axis of symmetry, by the way, my vertex has a y coordinate of 4. So what have I just discovered? One, I know that the vertex is always on the axis of symmetry. But if it has a y-coordinate of 4, then wouldn't it be the point 3, 4? Step 3, ask yourself, is the parabola concave up or concave down? Is it opening upward or opening downward? Well, that depends on whether the value of A is positive or negative. Look at the very top of your screen. Remind yourself that A is -1 here. The coefficient of x squared is A. And since A is -1, I'm going to have a concave down parabola. But in general, watch the bottom of the screen, if A is positive, which it's not in this case, the parabola will be concave up. If A is negative, then the parabola will be concave down. And in this problem in particular, A is -1, and therefore we're going to have a concave down parabola in this case. So now I know that, take a look at the vertex as I'm saying this. I know that that's going to be the high point of this parabola. Because if the vertex is always going to be the highest or lowest point, it is the turning point after all, then the parabola might look like this. But maybe it's more narrow, or maybe it's much wider. But I do know it has to be concave down and have 3, 4 as its turning point. So the next question is, how do I find the width of the parabola? Well, if A is either 1 or -1, in this case it's -1. If A is either 1 or -1, there's an amazing trick called the 1-1-1-3-1-5 rule. Strange name. I'll tell you where I got that name in a moment. By the way, if A is any number other than 1 or -1, this trick needs modification and is not addressed by this video. So if you see an A value that isn't 1 or -1, you'll have to watch different videos to address how wide or narrow your parabola is going to be. The good news is that A is either 1 or -1 most of the time. In most math classes, not all, but in most math classes, that's very common, so this should handle most of the cases. Here's what the 1-1-1-3-1-5 rule means. Watch the vertex of the parabola. From there, I can go over 1 and down 1 in either direction. Then over 1 more and down 3. Then over 1 more and down 5. Every time you go over 1, your parabola y-coordinate changes by the next odd number. In fact, if I wanted this parabola to go even lower on my graph, I could call this the 1-1, 1-3, 1-5, 1-7 rule, following the pattern of odd numbers. But usually this is enough points where I don't need to do over 1 and down 7 to get the next two. Once you have the points plotted, and this is assuming A is 1 or -1, then you can just draw a parabola through there and you're essentially done. And it's those 4 steps that will get you through most parabolas. But I do want to go on to step 5 and 6 just to show you a little bit more information, even though we're technically done with this problem. Finding the y-intercept. Now, in this particular problem, the 1-1-1-3-1-5 rule landed us right on the y-intercept. You can stare at the y-intercept right now and see that it's -5. But let's say the 1-1-1-3-1-5 rule didn't identify that. A more general procedure for finding y-intercept is to set x equal to 0 in the original problem. By the way, this is broader than just a parabola rule. This is an every graph rule. No matter what shape you're graphing in the future, straight lines, circles, cubic functions, logarithmic functions, doesn't matter. The generic procedure for finding any y-intercept is always to set x equal to 0. So look at the top of the screen, you'll notice our original problem there. Now look at the bottom of the screen. I've now plugged in 0 to the original problem. And working out the math, leads me to a y-intercept of -5. Here's my y-intercept. You can see that it's -5. No surprise. Oh, cool shortcut. Look at the top of the screen at the equation. The y-intercept is always your c value. If c is -5 in this problem, then the y-intercept is -5. Nice shortcut. Finally, step 6 is the x-intercepts. Now look at the x-axis and look where the graph crosses the x-axis. We can see that this parabola has x-intercepts of 1 and 5, if I'm counting right. Yes. So we don't really need any procedure to find the x-intercepts in this problem because the 1, 3, 5 trick brought us directly to them. But there are times when that won't happen. Suppose you want to find the x-intercepts in those cases. Well, in general, the way we find x-intercepts is we set y equal to 0. Again, this isn't just a parabola rule. This is any kind of graph you're ever dealing with rule. Past, present, or future math classes, y equals 0 is always the way to find the x-intercepts. So look at the top of your screen. There's the original equation. See how it starts with y equals? Now look at the bottom of the screen. I'm going to replace that y with a 0. And I'm going to solve for x here to find the x-intercepts. Of course, in this problem, I already know what they are. But in general, let me show you this. Now, in this problem, you could use the quadratic formula. Using the a, b, and c of the problem and plugging them in to a quadratic formula will give you the x-intercepts. For me, though, there's a little bit easier technique here. I did something a little different. I multiplied the whole equation by -1. Reason? Well, first of all, notice I changed all the signs in the equation. I did that so that it would be easier to factor the polynomial on the right and then see what the solutions are. And in this case, they're 5 and 1. If this is not how you would have solved the problem, then no worries. Just use the quadratic formula using your a, b, and c value from the original problem. And you will get these same two answers that I did. So watch the graph. We now know we have two x-intercepts. Here they are. And that completes this problem and this video. And I hope this gives you success in the work that you're about to start. Thank you so much for watching.